The final exam, I think it will be simpler than the midterm. That's what I want to do. And so there's a chance that I didn't decide it yet. There's a chance that I might have more yes or no problem, math calculations problems. That means there's a chance that we might have a 60% of yes and no problems, and then only 40% for you to do some calculations, some problems, just like what we had in the midterm. I don't know yet. I didn't decide yet. And we may have the same thing, just the same 40% of yes and no problem, and then 60% calculation problem. But if we have a 60% yes and no problems, then we don't need really 3 hours, maybe two hours, like that, because I try to make the problem simple and return. Okay, and this is the last homework. Say homework 10. This is exactly the same as my examples. That's what I'm going to show you today. You can just follow step by step. And you better do the homework before the exam, the final exam. You might find out that the final exam is very similar to this homework 10. So I really suggest that you do by yourself, solve the problem, and that's what I suggest you to do. And that is because the predictive control is the control design for discrete time model. So it must begin with the discrete time model. So anyway, this is just for you to do some exercise, some practice. It's a very easy problem, only 2 by 2 problem. Okay, so now you gotta be listen carefully. Today I'm gonna talk. Let me just skip on this, because we know that we have, this is our important equations. That important equation is this on the top, y, k, I think that this is the equation we are talking about. Just refresh your memory what we discussed about 2 weeks ago. Now we have to compute the T matrix, the B matrix, and A matrix. Well, this script T, script B, and script A matrix, that's what we need to do. And I already say that the TBA typically are computed from your data. The data from input and output data, and that's what we call system ID. So in theory or in practice, T, B, and A are really computed from the data. It's called observer macroparameters alpha and beta, and alpha and beta are computed from the input and output data. Right? Okay. From that, we have almost exactly the same as optimal control law. We also define a Q, define an R. Q, the same as the optimal control, the weighting matrix Q are positive, semi-definite, semi-positive definite matrix, and R must be positive definite matrix. So R must be larger than 0. That's exactly the same thing. From here, Because we define that, and we minimize J with respect to U, that's our input, our feedback, then we got these combinations, right? Okay. Now, then we got this, well, this is all these just formulations. Okay, let us look at example. So this example, listen carefully because that example is the procedures to determine your control force is exactly the same you are going to use for your homework 10. Alright, so this is A is 2 by 2, B is 2 by 1, and C is 1 by 2. And this is single input, single output case. And where gamma is a sample interval. This is just a sample interval. And in homework, I think I give you also the gamma, right? You don't really need gamma because I give you A matrix, B matrix, and C matrix. So, that's already given. Then observer model, because I assume I know A, B, C, right? But that's not, practically we don't do this way. This is just a way to show you how to compute the script T, script A, script B. Alright? So, from observer model, we know G, and G is a 2 by 1 vector. And from that, we know A bar equal to A plus GC, and that's the 2 by 2 matrix. And then we have a B bar is P plus GD minus G. This is also 2 by 2. And again, gamma is your sample interval. And this G is the observer gain matrix. Gives you the that B eigenvalue. That B eigenvalue means eigenvalue are 0. So from here, the A bar square, you know the A bar square for this case will be 0, 0, 0, and 0, 0, 0, 0. This computer is not really good. So I turn off the screen from this side. Anyway, now this A bar square here is 0, 0, 0, 0. That's the A bar square. Alright, that G gives you that. And eigenvalues of A bar are 0. Both eigenvalues are 0. Alright? And so I have that. What I try to do is I try to get I try to compute my alpha and beta of my finite difference model. And your homework, I already give you the value. Alright? So you don't need gamma. So from here, we'll be able to compute alpha and beta. And the beta 0 equal to D. And beta 1 equal to C, parenthesis B plus GD, parenthesis minus 1 plus parenthesis 1 minus 2D, parenthesis cosine gamma. Beta 2 equal to C A bar, and then B plus GD, parenthesis equal to cosine gamma minus 1 plus D. Beta 3, beta 4, and so on to beta infinity are all 0 because A bar square, they're all 0, 0, 0, 0. So you don't have any values, because the beta 3 will equal to CA bar square, and because that square is 0, 0, 0, 0. The same thing alpha 1, alpha 2, and this is the formulations. Okay. This is just mathematics. Again, in real case, we don't compute this way because we don't know ABCD. Right? Just an example. All right. So in practice, that alpha 1, alpha 2, alpha 3, and so on, and to alpha, maybe say 10. This is an example. Beta 0, beta 1, beta 2, and beta 10 are computed from input and output data. Using system identification method, right? That's in practice. But if I know ABCD, I can do this way. All right. So this is just the way I show you for you to understand how you compute alpha and beta. In theory, that in mathematics, that you can do just the way what I show you in this slide. Okay. Now this is because this is only a simple math point. That's 1 degree of freedoms. Then 1 degree of freedoms, we have the matrix A is 2 by 2. So if you look at this single input, single output, then we have only 3 beta. So for our case here, that this is all 0, this is all 0, and everything more than 3 are all 0, right? But in our case, so we have only 3 beta and 2 alpha. Based on that, we'll be able to compute our finite difference model. Now that is our finite difference model. That means yk, the current y output k plus alpha 1, the past yk minus 1 plus alpha 2, the past output k minus 2 equal to beta 0 uk plus beta 1 uk minus 1 plus beta 2 uk minus 2. Okay, that's the purpose of alpha and beta, and also this alpha and beta here, this alpha and beta are called observer Markov parameters. Okay, so we call observer Markov parameters. All right. So if you sub all the value in there, then you will get this. Now your homework, the same thing, your homework is to follow this process. Then you will get your alpha, you will get your beta. You better use your hand, right? To calculate it. It's easy for your homework problem because the gamma is fixed. after this, after we have finite symbolic, we have alpha, beta, then we can compute our call the script t. Now we want to compute our script t, right? Now what is our script t? Now the formulation of script t is this. Beta 0 parenthesis q equal to beta 1 q minus 1 minus alpha 1 q minus 1 beta 0. And then when q equal to 1, then beta 1 parenthesis 0 is beta 1 minus alpha 1 0 beta 0. Then you sub your beta 1, your alpha 1 and beta 0 into this formulation, then you got beta 0 parenthesis 1 equal to cosine gamma minus 1. That's your first t. Then you can form your t, 2 by 2 only. So you really compute on the one, just the beta 0 parenthesis 1. So you got beta 0, beta 0, 1, and beta 0, 0. Then you got a d. That's your direct transformation method term called d term. 0 cosine gamma minus 1 d. So that's my t, right? It's very simple. It's the same thing in your homework 10 will be as simple as like this. So you have t is 2 by 2, and I want to also make a remark here. The t, matter of fact, this t here, the first term, if you look carefully, this t here, we have this called d 0 and cosine gamma minus 1 d. Right. Let me go back a little bit, because there's a magic here. I want to remind you, give you some hint here. Let me go back. What is my a? My a here, I want to copy here a equal to cosine gamma and sine gamma minus sine gamma cosine gamma, and my b here is equal to 1 minus cosine gamma and sine gamma, and c is minus 1, 0, and d equal to d. Okay, if you look at carefully, the first term d here, this d, is exactly the same as my d. And then this term, if I put CB here, C is equal to minus 1, 0, and B is 1 minus cosine gamma sine gamma. And that equal to what? That equal to minus 1 times 1 minus cosine gamma, that equal to cosine gamma minus 1. Right? And that is exact to be that term. So the t term, this script t here, that d0 CBD, right? So that is, because that d is that d, and this is CB. So this is the same thing. This T term has not, there's no G involved. No observer gain involved. Alright. And what does that mean? DCB here, D. Okay. So, do you catch this? Alright. Okay. Now, let me just erase this. So in general T, if we that will be D 0, 0, for example, CB, B 0, CAB, CB 0. If I have the three terms, will be like this, and you can extend it, keep writing like that. So that is the T term. And what is this? D, CB, CAB, CA square B. What is this? This is the pulse response. Great. All right. Let's do this. You have a model equal to A xk plus BUK and YK equal to CXK plus DUK. Now, when you 0 equal to 1, U1 and U2 and to that's equal to 0, then we will find out that x0 equal to B, right? Now y0 equal to D. No, I'm sorry, that's not right. That's not true. X0, assume x0 equals 0, initial condition x0 equal to 0, then y0 equal to D, that's from here. Now x1 then equal to B, U1 that equal to B. Now y1 equal to CX1 equal to CB. Now x2 equal to A x1 plus BU B1, then that's equal to AB. So y2 equal to CX2 equal to CAB, right? So we have this, we have that, we have that. Now we give them the pulse. U0 equal to 1, U1 and U2 all equal to 0, and that is, we call the pulse input. Alright? So the pulse input gives you the pulse response. Y0 equal to D, Y1 equal to CB, and Y2 equal to CAB. That's exactly it. T equal to D 0 0, T CB D 0, CAB CB 0. If you have more, then you can just keep going. That means this quick T is really formed by pulse response. Understand? Do? Right? Am I doing right? Any why you have an error here. In your example, you just copy this error. You still, that's always still wrong, no? Okay. What message I try to pass to you? The message I try to pass to you is this squid T matrix is really formed by the pulse response. That's all. That's the message. So, the T, this T, the T is formed by pulse response. Okay, that's this, and that's this. So this is the message I tried to give to you. All right, so we know, now we have a T. Now we have a T. We got T, that's our T. So that T is now from the pulse response. Now, what is the B, the squid B for the past input? Now, you need to use these formulations. The beta Q, super Q, and sub P minus 1 equal to beta super Q minus 1, sub P minus alpha 1, and super Q minus 1, and beta P minus 1. Okay, let us calculate that. So that is this. When Q equal to 1, then beta parenthesis 1 equal to beta 2 minus alpha 1 beta 1. And then you sub the beta 1 and alpha 1 into these formulations. And then you will get these formulations. You got a long term, that's parenthesis cosine gamma minus 1. And then parenthesis 1 plus 2 cosine gamma plus d minus 4d cosine square gamma and so on. This is a long term. Of course, now when you know the d, you know the gamma, and this is just a number. Beta 2 parenthesis 1 equal to minus alpha 1 beta 2 is just plug into this formulation. Then you got this. The result. 2 cosine gamma parenthesis cosine gamma minus 1 plus d parenthesis. Okay. This recursive formula is very easy to compute. This is just used by hand. Again, when you do your homework 10, you just follow this process, and you will get your solutions. Now, the reason I keep gamma here, I keep sample interval here, just to let you know that all this beta and alpha, the parenthesis, the super beta, super 1, sub 1, and beta 2, super 1, they are sample interval dependent. If gamma has a different value, then your this beta 1 and parenthesis 1 will be different values. And the same thing, you have a different d, then you got a different value of this the squid beta. Alright? So after compute this, then we got our squid B, the squid B that equal to 2 by 2 matrix. And this 2 by 2 matrix become on the right hand side like that. And they are sample interval dependent. And your direct transmission term D dependent. Okay, listen carefully, because they always got a concept here that you need to understand. Although I have a formulation here, this formulation you can program it in the side app or mat app, you can just compute it very easily for single input and single output. For multiple input and multiple output, and of course it's more complicated than this. Now we compute the T here, and we compute the B here, this squid B here. We compute this T and B. Then what is the A? There is squid A. Then I continue this. Then squid A. It's nothing but just plug into the recursive formula to do the computation, right? Again, the alpha 1, when Q equal to 1, then alpha squid 1, alpha super parenthesis 1 parenthesis sub 1 equal to alpha 2, because this Q minus 1 equal to 0, 1 minus 1, 0, that means that is just the observer macroparameters. That means we have alpha 2 minus alpha 1 times alpha 1 is the same thing. The P here, P start from 2. 2 minus 1 equal to 1, and this P equal to 2, then that is equal to 2 here. This 1, and P2 minus 1, that's equal to 1. Alright? These formulations is easy to compute. Then we got the squid A. That's my squid A. Then you need to go on to do some exercise, then you know how to do it. Any questions? This recursive formulation, is just like a magic. If you know the previous value, then it can keep going until you got no alpha anymore. For this example, the maximum the alpha will be alpha 2, sub 2. The alpha sub 3, 0, alpha sub 4, 0, so we don't have those values anymore. So this is why A is only 2 by 2. Okay, as soon as we got A, this squid A and squid B and T, then we can form the output. Then we can form this output prediction matrix. If gamma equal to parenthesis 2i plus 1 parenthesis pi over 2, assume that, then we got this. When we sub this, why I put this, because if I is gamma in that range, then cosine and sine gamma will be simple. That's why I just assume that. Now, if gamma equal to that 2i plus 1 pi over 2, then cosine gamma equal to 1 and sine gamma equal to 0, right? For any I. For any I. Alright. Upside down. When I equal to 0, then I equal to 0 on 2 pi. So that's upside down. True? Don't just keep copying what I write here. When I equal to 0, this is pi over 2. cosine pi over 2 equals 0, sine pi over 2 equals 1. When I equal 1, then that's, right? Then that's 5 pi over 2. It's the same thing. Agree? Okay? If I got that, then you sub all the cosine and sine value in it, then I will have this. This m equal to 1 here means I have single input and single output and single input. The m here represent the number of outputs. The r here represent the number of inputs. And this h sub p equal to 2 means I have only 2 by 2 here. That's SP and SC equal to 2. So I have a SP equal to 2, SC equal to 2, so I have a 2 by 2 here. That's what it means. If you go back to look at the formulations, then you will see what happens. Okay, now, if I have this, assume the gamma satisfy this formula, then I can simplify my t, script t, and script b, and script a, and script b here. And that is my formulation. See, you look at this, very simple formulations. A simple formulation for you to determine the input. Okay, now, control equations. That's my control equations, right? That's my control equations. So I have to know Q, and I have to know R. Then what is the Q will be good for me, what R will be good for you. Then I assume Q equal to I, this Q equal I means the identity matrix. So that I assume Q equal to I, for this case, E1001. Then let us assume R equal to lambda 1001. And lambda is just a constant. And this has to be a positive constant. Right? Because this positive has to be positive. And my desired output will be 0. See, that's what I want to, just like earthquake in Sunday. My desired output after earthquake, of course I want to make sure that I don't have any output. If I do this, then I will be able to solve my UC, that's my control C, UC K and UC K plus 1. I will be able to solve this equation become like this. Alright, you don't worry about how I solve it, but I solve it just by simple hand. Now, the reason why I keep D here, and I keep alpha here, I will let you know how important of my lambda is lambda. Here's lambda. Alright? Now I have a Q equal identity matrix. In general, we always assume Q is the identity matrix. So in practice, if you want to use this method for your thesis, then you can always assume I is equal identity matrix, Q equal identity matrix. This in practice we assume that because only relative value of Q and R really affect your controller design. So you have alpha, you have the you have R here, kept R. The same thing in practice, we always do like this because we don't want to have too many parameters we have to adjust. So we have only lambda here we need to adjust. Okay. That's in practice. That's what we always do this way. So if you look at the formulation here, we have D, we have lambda. Now, so the control force really is a function of D and function of lambda. Lambda is a weighting terms. It's weighting for your control. Okay. Now, why I want to keep D here? D. D is your direct transmission term. Now we know that we already showed you earlier. If we have a Excel sensors, in mechanical system, I'm going to give you some hint here. In mechanical system, the D, the direct transmission term, D exists only for acceleration measurement. If your device, your measurement device are not accelerations, then there's no D. That means D equals 0. So I keep D here because D is important in control design. Some control design, some control design, they really need a D term for their control design to exist. All right, so that's why I have a D here and I have lambda here. So lambda, so in this formulation we have a D and lambda. So you see here now, you see K and you see K plus 1. Now this is function of, here this is function of lambda and D. Right? This function of lambda and D. So I'm going to show you how important of that. So this control, now our feedback control UCK and UCK plus 1, and as soon as the D is giving, lambda is giving, then if we have a past output measurement and we have a past input data, then we'll be able to compute the control force, UCK and UCK plus 1. Okay? All right, now let's go to the next page. Assume D equals 0. There's a term here called non-minimum phase. All right, non-minimum phase. D, assume D equals 0. D equals 0, we call non-minimum phase. If there's no D, then you have non-minimum phase, we call non-minimum phase controller design. The control equation becomes this. Become very simple. It depends only on your lambda. Okay. watch this. That means our UCK, this UCK, that's what we want. UCK that means my control force at the current time K will be equal to minus 1 divided by lambda plus 1, then y k minus 1 plus UCK minus 1. Look at that. So simple. Now you might want to say, why don't we use UCK plus 1? Now what is our UCK plus 1 for this case? Just UCK plus 1 equal to 0. No UCK plus 1 involved at all there. But UCK equal to this. Alright? Let me just copy again here because there's an important concept here we need to understand. This shows you how importance of your lambda. That means your weighting. Equal to minus 1 lambda plus 1 and y k minus 1 plus UCK minus 1 and for k equal to 2, 3, and so on. Right? Okay, now let's look at lambda. For lambda equal to 0, because can lambda equal to 0? That's the question. What is lambda? Huh? What is lambda? Let us look at this. Okay. R, my R is lambda times 1001. So, but this one has to be partially definite. Right? So lambda cannot be 0. Right? Alright. But now if lambda approach to 0, you say, I'm not going to use 0. I say approach to 0. Small, very small. That means my UCK approach to what? To minus y k minus 1 plus UCK minus 1. Right? I mean approach. Now, when lambda going to infinitive, then what happens? What's UCK? If lambda going to infinitive, then UCK equals 0. Right? Agree? Any questions? No? Okay. Let me explain to you here. Lambda going infinitive, then UCK equals 0. I think let us take a 10 minutes break here. Let's just think about it, and we discuss further, because this is important.